One of the most important roles of biostatistics in public health is to provide the evidence. And by evidence, we mean data to make objective decisions about public health, about science, about medicine. When you hear the phrase evidence-based research or evidence-based medicine, what that means is the collection of data to objectively analyze and answer questions. So let's look at some objectives. How do you collect data and what your data can do? You need to define your population. Once you define your population, you can determine the kinds of inferences that can be made. You need to determine the sample that you will take from your population. And you will compare sampling strategies. What is the best way to take that sample? And then what is the study design that you'll be doing? We'll compare observational and experimental study designs and apply those to questions at hand. So what is a population? In general, population is defined as all the inhabitants of a particular town, area, or country, a particular section, group, or type of people, or the total number of people in a defined group. That's a very broad definition of population. You think about the population in terms of the population of Birmingham. That's defined as the people that live within the prescribed geographical area. You could think about the population of UAB students. So that would be any currently enrolled student at the University of Alabama at Birmingham. So any general or broad group is defined as a population. In statistics, our population is an entire pool from which our sample is drawn. So again, it may be an entire group of people, but it could also be objects or events. It could be hospital visits, it could be hospitals, it could be physicians, it could be water samples. It could be an aggregate of participants grouped together by a common feature. So our population in statistics is an entire group with a common feature of which we can take samples to do some data analysis on. What we want to do is use a sample to make inference back to the population. It's going to be very difficult to collect everyone in an entire population, not just logistically because it's time consuming and cost prohibitive or logistically challenging, but simply because it's not possible. If you think about the census in the United States, it's not actually a census, it's a sample. They try very, very hard to collect as much information from as many people as possible. But some people simply don't respond to the census. Some people are not home when the census taker comes by. Some people do not have a home or a place to live and therefore are underrepresented. What we want to do is take a sample that is representative of the population so that we can make inference back to that population. To infer means to make a conclusion reached on the basis of evidence and reasoning. In statistics, we form judgments about a specific population on the basis of random data sampling. So if we take a good sample, what we learn from that sample, we can infer back to the population at large. So consider student athletes. What defines this population? Who is included in this population and who is excluded from this population? If you think about student athletes, part of that population definition is in the name. They must be students and they must be athletes. But is there a more fine definition? So who's included in that population? Do they have to be students on athletic teams that are sanctioned by the university? Could they be students who are on club teams? Could they be students who simply attend the gym on a regular basis? What defines athlete? And who would be excluded from this population? So don't just think about inclusion into the population, think about exclusion. Do they have to be active athletes? Sometimes managers are considered part of a team. Does that mean they are a student athlete, or do they have to have a prescribed role on the team to be considered a student athlete? Once you've defined the population, how do we get people, or how do we sample from that population to get our data? So you generally can't collect an entire population. Again, logistically difficult, time-consuming, and cost-prohibitive. So what do? You take a sample. Define your population, then think about how you'll find people, and think about how many people you need. So how do you identify the people within the population, and what number or how many people do you need to include in your particular research project? So how do you get them, and what do you ask? There are various sampling strategies that are well accepted in statistics. The most simple being a simple random sample. So all potential respondents or participants have an equal chance of being selected or an equal chance of being in your sample. So how do you find them, get them, and how many? So think back to the student athlete example. For a simple random sample, all student athletes at UAB would be invited to participate in your survey. So you could send out emails, you could post it on Canvas, you could send notifications to the coaches or managers of the team, you could post flyers in and around locker rooms and places where athletes congregate. So there are many different ways to get a simple random sample. The other option is to do a convenience sample. So drawing from people that you have, drawing from people that are likely to respond or participate. However, a convenience sample may not be representative of the population as a whole. And therefore, if they're not representative, the results may not be generalizable to broader populations. So again, back to the student athlete example. If you simply go to basketball practice, then you're only going to get basketball athletes. The results from that survey will not necessarily be generalizable to football players, to tennis players, to those that play golf, to those that run track. So a convenient sample, while convenient, given the name, may not be the route to go if you're looking for representative and generalizable results. It doesn't mean that you can't gain any insight into your question of interest. It just is going to be slightly biased, or maybe very biased, depending upon the sample that you chose. And that brings us to bias. Sampling some people but not others. It doesn't represent the population. It will not be generalizable. And a big warning here is that statistics cannot fix this problem. If you only include men in your sample, there is no amount of fancy statistical analysis that will make those results generalizable to women. If you only include basketball players, you will not be able to generalize those results to swimmers, for example. So think about the biases, think about who you want these results to apply to, and then do your best to get a representative sample. Once you've defined your population and you know generally the sample that you're trying to get to represent your population, how many do you need? And that's where sample size comes in. Sample size, what data do you need and how many units do you need that data to be collected upon? So first you need to define your unit of observation. This is what you will be measuring the outcome on. Most commonly, particularly in public health and in medicine, we're talking about a person. Unit of observation is a person, is an individual respondent. But that doesn't have to be the case. It could be a place. Plenty of research is done at the institution level. So you could be comparing rates of discharge or rates of admission to hospitals. And in that case, the hospital is the unit of study. You could be looking at water samples from streams or bodies of water that are near farms. And in that case, the unit of observation is the body of water. So make sure you understand the unit of observation. Is it person level data, institution level data? Is it physician level data? Is it a thing? Are you collecting data on cars? Are you collecting data on houses, on buildings, on streets? So think about your unit of observation. And once you've done that, you'll need to determine the sample size, or N. We've seen N with N%. N means number, and this is how many units you will collect to answer your question. Determining your sample size is one of the things that biostatisticians spend a lot of time doing. If you can pick your size, you need to know the following. And when I say if you can pick your sample size may be determined for you if you're surveying a class or a team or a certain medical clinic. You may be restricted to a sample size, but if you can choose your sample size, you need to know your outcome measure. So your question has to be defined, and how are you going to measure or answer that question? how precise the outcome measure is. So what is the spread or variability? The more precise, the better. And from there, you need to define your hypotheses. So if you think back to the definition of the null and alternative hypotheses, you need to have an idea of how often you're willing to make the wrong conclusion. So how often are you willing to choose the yes answer when the true answer is really no? And then how sure do you want to be that you're going to make the right conclusion? These are statistical concepts. When you are planning a study, find yourself a statistician. They will help you determine the sample size. There are many moving parts other than the ones listed here. If you want to do a large reproducible or a randomized clinical trial or a long-term longitudinal registry, please, please, please contact a statistician to talk about sample size. So once you've defined your population and you've determined your sample and you've gotten an idea of what type of sample size you need, from there, we need to figure out how exactly you will go about collecting that data and what inferences you can make. For the first part of the activity, review the 4 studies, the links are given on the practice worksheet, and answer the questions about the study design, the study type, the study outcomes, and the study sample. You only need to read the abstract from the link to answer these questions.